This is your video for lesson 11.4, Inequalities with Rational Numbers. We're working with the same TEKs that we've worked with for the entire chapter 11. Also for this lesson, you're going to use the same methods that you learned in lesson 11.2 for solving equations with fractions and decimals. I did put some notes here for you based upon the previous lessons. The first thing is we need to make sure that we always write the inequality. Second, if we have fractions, you're going to multiply each term by the lowest common multiple so that we can get rid of the fractions. If you have decimals, you will multiply each term by the power of 10. That eliminates the decimals. And we will check the solution for reasonableness. There is one other note that I do need you to write that I did not put, and it is, if multiplying or dividing by a negative, flip the inequality symbol for a true solution. And you will see what I mean by that as we move through the lesson. For example 1, we need to write an inequality using fractions to represent this statement, and then we're going to solve the inequality. 2/5 of a number is greater than 2 times the number minus 8. That would be our inequality for this statement. Now we're going to go through and solve it. Although we only have one fraction, we're not going to change it. We will multiply each term by the least common multiple. So because we only have one, we know that that multiple would be 5. Once you multiplied each term times by 5 and simplified, you should have came up with 2 times x is greater than 10 times x minus 40. When you have inequalities, you want to put all of your variable terms to the left and your constant terms to the right. So that means I need to move the 10x over to the left. Once I did that, I have a negative 10x plus 2x is greater than negative 40. And I have a negative 8x will be greater than negative 40. I have to divide both sides by the negative 8 so that I can get x by itself. And once I have done that, x is less than 5. Because I divided by a negative, I need to flip the inequality symbol so that my solution is true. If I did not flip it, that would be saying that x could be greater than 5. And if you were to put in, for example, the number 6 in for x, you would see that in the end you would not have a true statement. So let's check this, our solution in our inequality to see if we have a true solution. For it to be true, I just need to choose any number that is smaller than 5. So for example, I'm going to choose the number 4. So I have 8 over 5 is greater than 8 minus 8. When I divide 5 into 8, I get 1.6 is greater than 0. That is a true statement. So because that is a true statement, I know that this is the solution to my inequality. Let's apply the information that we've learned to a real-world situation. So example 2, you've been given a real-world situation. We're going to pause the video so that you can read it and write your own inequality. Then hopefully you have the same thing that I have. So the inequality that I came up with was 16 and 5/10 minus 15 hundredths times x is less than 8 and 45 hundredths minus 5 hundredths times x. And because I have decimals, I'm going to multiply each term by the power of 10 that eliminates the decimal. So because my largest power, or my largest decimal is going to be the hundredths place, I'm going to multiply each term by 100. So after you multiplied each term by 100, hopefully you came up with the same information that I have. Now I'm going to go through and move again my variable terms to the left, my constant terms to the right. Now that I've done that, I can go through and work it out. I need to divide by -10. And because I divided by -10, I know that x will be greater than 80.5. To verify that this is a solution, the only thing I have to do is choose a number greater than 80.5, replace it in my original inequality, work it out, and I should have a true statement. So for example, I want you to put in the number 81, replace x with the number 81 to verify this information. So we're going to pause the video for a moment just so that you can do that to verify that we have a true solution. So to answer the question, when will there be less water in the larger bottle than there is in the smaller bottle? The answer would be at any time after more than 80.5 hours have elapsed. Let's move on to example 3. Example 3, we're going to do the same thing. Pause the video again so that you can read it. If you're doing this video at home, please pause it, write your own inequality, then restart the video to verify that you wrote the correct inequality. Looking at the question, it said, at what amount of sales will T earn more than S? So I know that T has to be greater than S for my inequality. You should have had 300 plus 1/10 times x is greater than 400 plus 200 times x. Remember, if we have a percent, we change that percent to a decimal, and then you're just multiplying it times x. Now, I do have decimals. I'm looking, I have 1/10 and I have 200s. Because 200s is bigger than the 1/10, I'm going to, and when I'm saying bigger than, I'm talking about the power of 10. I'm going to multiply all terms by 100. Once you did all of your multiplication, hopefully you came up with the same thing I have, which is 30,000 plus 10 times x is greater than 40,000 plus 2 times x. Now I'm going to move all of my variable terms to the left, my constant terms to the right. When I do that, I have 8x is greater than 10,000. I'm going to divide both sides by 8. When we divide both sides by 8, you get x is greater than 1,250. So the answer here would be, at what amount of sales will T earn more than Shayna? It would be more than $1,250. And again, we can verify this by just choosing any number that is greater than 1,250. Put it in your original inequality. You will have a true statement. Let's move to our last example for this lesson. For the last example, you have been given an inequality and you're asked to write a real world situation that can be modeled by the inequality. We will pause the video, or you should pause the video, write your own example. I will, of course, provide you with an example, and then we're finished. And here's my real world situation to model the inequality. You earned $15.25 an hour. Your brother earns $10.25 an hour. You pay $30 a week for lunches, and your brother pays $15 a week. If both of you work the same number of hours in a week, how many hours do you have to work so that the amount of money you have is greater than the amount your brother has after you both pay for lunch? This will conclude this video for this lesson. You all have a great day.